Let's do an example with multiple transformations. So given the following function, k of x equals x plus 2 cubed minus 3. So first, note to self, what is my parent function? Well, I'm going to say f of x equals x cubed, because that is what I see in this function k of x. So hang on to that for a minute, but let's list the transformations of that parent function x cubed. So I see one horizontal and one vertical transformation. Really doesn't matter which one of these you list first, since it's really separate transformations in the x and the y direction. So let's maybe do the horizontal one first. A horizontal shift. Now remember, when it says x plus 2, that's really a shift left 2 units. And then we have another transformation, and that's a vertical shift down 3 units. And that's all we have. Now I'm going to work through how to show what happens to each component of the coordinates one step at a time. So remember, we said the parent graph. The parent function is y equals x cubed. So what are we going to do? Well, we said there was a horizontal shift left 2 units, so we're going to subtract two from x values. And then we said there's a vertical shift down 3, so we're also going to subtract 3 from the y values. Again, just hang on to that for a second. I'm going to put the parent graph x cubed in this first column. And the key points of x cubed that give us the shape of the S-curve that we've seen are -1, -1, 0, 0, and 1, 1. When we apply the two transformations to get what is x plus 2 cubed minus 3, well, we said we're going to subtract 2 from all the x values. So -1 minus 2 is -3, 0 minus 2 is -2, and 1 minus 2 is -1. So I'm done transforming the x values, and now I need to subtract 3 from the y values. So if I take -1 minus 3, I get -4. If I take 0 minus 3, I get -3. And if I take 1 minus 3, I get -2. So remember, these were two rigid transformations, so the shape of our S-curve will look exactly like the parent graph, or a snake as we called it. So if I go and I graph -3, -4, and -2, -3, and -1, -2, now it's hard to see the shape here, but we know it looks like an S-curve. So we can kind of sketch it like this. And preserve the shape because these were two rigid transformations. So again, what we had to recall was that x cubed went through the origin and had a snake shape, and then the two transformations were rigid and they preserved that shape. So we gave a little curve through -2, -3, because that is where the origin transformed to.